August 15th, 1977. A signal arrived at Earth. It lasted 72 seconds. It came from a specific patch of sky in the constellation Sagittarius. It has never been explained, and something with the same fingerprint has been arriving from approximately the same direction, in scattered fragments, ever since. That is the situation. That is what the field has been holding on to for nearly 5 decades. Not a one-time anomaly that was investigated, resolved, and filed away. A signature that arrived once, presented every characteristic of a deliberate transmission, defied every attempt at explanation, and then continued, at the edge of detection, to leave traces in the data that no one in radio astronomy has been able to reconcile with any natural source. The signal has a name. It has a code. It has a designation in every catalogue of unexplained astronomical events that radio astronomers maintain. It also has, written in the margin of the original printout, a single word that was added by the astronomer who first noticed it. He circled the numerical readings. He drew an arrow from the circle to the margin, and he wrote one word. Wow. That is what the signal has been called ever since. The wow signal. Because the readings were so far beyond the background noise, so improbable, so close to what the field had been waiting decades to find, that the only annotation the astronomer could produce in that moment was a 3-letter exclamation in red ink on a piece of green bar computer paper. The paper still exists. The signal does not. We are going to spend the next 2 hours with this story. We are going to walk through what the signal was, what it should have been, what it could not have been, and what the absence of any successful explanation across nearly 50 years actually implies. We will look at the explanations that have been proposed. We will see how each one was tested. We will see how each one failed. And we will end at a question that the field has not yet answered, and may never answer, but which sits in the data as an unresolved presence that the listener is now part of, simply by knowing about it. The signal has been waiting. The field has been waiting. You are about to be part of the waiting too. Before we can understand what made the wow signal so disturbing, we have to understand what radio astronomy was in the summer of 1977. The discipline had been operating, at that point, for about 40 years. The first radio detection of an astronomical source had been made by Karl Jansky in the early 1930s, when he identified a steady hiss coming from the direction of the galactic center. The hiss was not from any star he could see. It was the radio emission of the galactic plasma itself, of charged particles spiraling in the magnetic fields of the Milky Way. It opened a new window onto the universe. Everything bright, invisible light was, it turned out, also doing things at radio wavelengths that visible light could not show. By the 1970s, the field had matured. Radio telescopes had been built across the world. Their data had revealed pulsars, quasars, cold gas clouds, hot remnants of supernovae. The cosmic microwave background, that faint glow left over from the universe's earliest moments, had been discovered at radio wavelengths in 1965. Radio astronomy had become one of the most productive branches of astronomy. The universe was, in the radio band, full of voices. Most of them belonged to the universe itself. The voices were, in the technical sense, well understood. A pulsar emits at a specific characteristic spectrum, and its emission has specific characteristic time profiles. A quasar emits across a broad range of frequencies, with characteristic broad-band features. A supernova remnant emits at frequencies that reflect the temperature and density of its expanding shell of gas. The hydrogen clouds drifting through interstellar space emit at the hydrogen line, but only weakly, with a broad spectral profile that reflects the thermal motion of the hydrogen atoms within them. Every catalogued source had a fingerprint. The fingerprint described not just where the source was, but what kind of source it was, how it was producing the emission, and what physical processes were driving the production. Radio astronomy, by the late 1970s, had developed an extensive library of these fingerprints. When a new source was detected, the astronomers reviewing the data could, in most cases, match the new detection against existing categories. A bright source with a flat spectrum and a small angular extent was probably a distant quasar. A source pulsing at millisecond intervals was probably a rapidly rotating neutron star. A source with broad emission lines in its spectrum was probably an active galaxy. The library kept growing. The number of unidentified sources kept shrinking. The universe was, in radio astronomy's experience, less and less full of mysteries. The question that the field had been quietly considering, almost from the beginning, was whether any of the voices belonged to anyone else. In 1960, an astronomer named Frank Drake had pointed a radio telescope at two specific stars and listened, for a period of weeks, for any sign of artificial signal. The project was called Project Ozma. It found nothing. The methodology was simple. If a civilization elsewhere in the galaxy were attempting to transmit a signal that could be detected across interstellar distances, the most natural frequency they would choose would be the one that already corresponded to the most fundamental and abundant feature of the cosmos: the hydrogen line. The hydrogen line, the frequency at which neutral hydrogen, the most abundant element in the universe, emits a faint natural signal. The frequency is 120 MHz. The wavelength is approximately 21 centimeters. Every radio astronomer in the world knew the frequency. Every civilization in the galaxy capable of doing radio astronomy would, by simple inevitability, also know the frequency. The hydrogen line was, in the framework that Drake and others were building, the universal calling card. The one frequency where you would tune in if you were looking for a signal that was not natural. The one frequency where you would transmit if you wanted to be found. Any civilization sufficiently advanced to do radio astronomy would have, very early in their development of the discipline, discovered the hydrogen line. The discovery is inevitable. Hydrogen is so abundant that any radio survey of the sky would, within weeks of beginning, reveal it. Once the line was discovered, it would become a reference frequency. It would become the frequency that every radio observatory in that civilization would monitor as a matter of course. If, then, a civilization wanted to transmit a signal that another civilization would notice, the hydrogen line was the natural choice. It was the one frequency on which the other civilization would already be listening. There was a second consideration that strengthened this argument. The hydrogen line, in addition to being the natural frequency for radio astronomy, sat in a part of the radio spectrum that was relatively quiet. The cosmic background radiation, while present at all radio frequencies, was particularly low, near 1420 MHz. Galactic radio noise was modest. The thermal noise of cold plasma was minimal. A transmitter operating at this frequency would have, in effect, a quiet channel. A signal would stand out against the background more clearly here than at most other frequencies. Any civilization optimizing for detectability would arrive at the hydrogen line by this logic as well. The international community of radio astronomers had, by the 1970s, gone so far as to formally protect the hydrogen line region from terrestrial interference. The frequencies near 1420 MHz were designated as a quiet band. Earth-based transmitters were prohibited from broadcasting in this region. The point was to keep the hydrogen line clear of human-made signals, so that any signal arriving there from elsewhere could be evaluated without confusion. The frequency was, in a real sense, set aside. It was the listening post for any conversation that might one day arrive. The Ohio State University Radio Observatory, in the summer of 1977, was operating a telescope called Big Ear. Big Ear was a radio telescope of an unusual design. It was not a single steerable dish. It was a stationary structure, roughly the size of 3 football fields, that swept the sky as the Earth rotated. 2 reflectors, one curved and one flat, channeled radio waves arriving from a narrow strip of sky into a set of detectors. Every 24 hours, the telescope would scan a full circle around the Earth, picking up radio emissions from every direction the strip swept across. The data was recorded on continuous printouts. Numerical values, 1 digit per channel, 1 channel per second, scrolling off a line printer onto folded green bar paper. The Big Ear telescope had been built in the 1960s, originally for a survey project that aimed to catalogue radio sources across a large portion of the sky. The survey had been completed by the early 1970s. After the survey ended, the observatory's leadership made a decision that, in retrospect, would prove consequential. They committed the telescope's continued operation to a long-term search for artificial radio signals from elsewhere in the galaxy. The telescope was, by the time the "Oh wow" signal arrived, one of the only major facilities in the world dedicated continuously to this kind of search. Other observatories looked for artificial signals occasionally, when their schedules permitted. Big Ear looked for them as a primary mission, every day, around the clock, year after year. The continuous operation meant that the telescope was, in some sense, always listening. The strip of sky overhead changed as the Earth rotated and as the seasons progressed. Different patches of the celestial sphere passed through the beam at different times of day and different times of year. Over the course of a year, almost the entire visible sky would pass through the beam at some point. The telescope was, in this manner, conducting an ongoing survey of the hydrogen line band across the entire accessible sky. Most of the time, the data looked like noise. The numbers were small, the background hiss of the cosmos, the occasional bright source as the strip swept past a known radio galaxy or a known quasar, pulsars, occasionally showing their regular periodic flashes. The numbers ran down the page, line after line, day after day. Astronomers reviewed the printouts manually. They were looking for anything that did not match the catalogue of known sources. The review process was, by today's standards, almost archaic. There was no software automation. There was no real-time alert system. The data was printed. The printouts were reviewed by human eyes. An astronomer would sit at a desk with a stack of green bar paper, scanning down columns of numbers, looking for any pattern that stood out. Most days, nothing stood out. Most weeks, nothing stood out. The discipline required for this kind of review was substantial. The reward for the discipline was the possibility, at some future moment, of catching something that no one had ever caught before. On August 15, 1977, the telescope was doing what it always did, scanning the strip of sky directly above it. The hydrogen line band was being monitored as part of the routine SETI observations the observatory had committed to. The data was being recorded. The printout was being produced. The astronomers were not present at the moment of the event itself. They would review the data later, in the days that followed. The signal came in around 11:16 Eastern Daylight Time. It built up, it peaked, it faded. The entire event lasted 72 seconds. A few days later, the astronomer reviewing the printouts came to the page that recorded that moment. He saw a sequence of numbers that, in radio astronomy, did not belong on a routine printout. The numbers represented signal strength at the hydrogen line frequency. Most of the time, the numbers in this column were 1s and 2s and 3s. Background. The numbers on this page were different. They built up smoothly. They peaked at 6U, then U, then again, with values that, on the Big Ear scale, indicated a signal more than 30 times above the background. They faded back to baseline over a duration of approximately 72 seconds. The astronomer reviewing the data was named Jerry Eman. He had been with the observatory for some years. He had reviewed many printouts. He had seen many bright sources sweep through the beam. He had never seen anything quite like this. The numbers, in radio astronomy notation, were 6, E, Q, U, J, 5. To anyone outside the field, the sequence looks meaningless. To Jerry Eman, the sequence meant a signal so far above the background that the printer had switched from displaying single digits to displaying letters of the alphabet in order to fit the magnitude into a single character column. The letter U represented a signal-to-noise ratio above 30. The signal was, at its peak, more than 30 times stronger than the surrounding noise. That was an enormous signal. That was the kind of signal a radio astronomer might see once in a career, if at all. He circled the sequence with his red pen. He drew an arrow to the margin. He wrote one word: "Wow." And then he began to investigate what had happened. The investigation has continued in various forms for nearly 50 years. Different teams have looked at different aspects of the data. Different telescopes have been pointed back at the same patch of sky. Different theoretical explanations have been proposed. Each of them has been examined. Each of them has been tested against the available data. And so far, every one of them has failed. We are going to walk through them now. We will go through the proposed explanations in approximately the order they were considered, beginning with the most ordinary and moving toward the most extraordinary. We will look at each one. We will see what made it plausible. We will see what made it fail. And we will end, after the last explanation has fallen, at the question that radio astronomy has been holding open for nearly 50 years. The first explanation was that the signal came from a passing satellite. This was the most natural first guess. The sky was full of satellites by 1977. Communications satellites, spy satellites, weather satellites. Some of them broadcast at frequencies near the hydrogen line. If a satellite had been passing through Big Ear's beam at the right moment, its broadcast could have produced the observed signal. The explanation was simple. The explanation was testable. The test was straightforward. The signal had been detected at a specific time, in a specific direction. The orbital trajectories of every satellite that existed in 1977 were, at least in principle, traceable. Investigators went through the catalogues of objects in orbit. They calculated which satellites had been above the horizon and in the right region of sky at the moment of detection. They found nothing. No satellite, at the time of the signal, had been in a position to produce it. The trajectories did not match. The frequencies did not match either, for the satellites that had been remotely nearby. The communications satellites of the era were forbidden from broadcasting in the protected hydrogen line band, and the investigators confirmed, by direct examination, that none of the satellites in the right region had been operating in that band. The satellite explanation failed. The second explanation was that the signal was a reflection, a military broadcast perhaps, a high-power radio transmission from a terrestrial source, bouncing off some atmospheric layer or some piece of orbital debris arriving at Big Ear by an indirect path. The Cold War was at its height. Military radio communications were continuous. If one of them had been broadcasting at the right frequency and the right direction, and if its signal had reflected off something, a satellite, the ionosphere, an aircraft, it could, in principle, have produced what Big Ear recorded. This explanation was harder to rule out completely. Military communications were not always disclosed. The full catalogue of broadcasts at any given moment was not available to civilian investigators. But the explanation was constrained by physics. For a reflected signal to produce the observed pattern, Several conditions had to be met simultaneously. The original broadcast had to be in the protected hydrogen line band, which would itself be a violation of international agreements, since that band was supposed to be kept clear. The reflection had to come from a specific direction. The duration of the signal had to match the duration of Big Ear's beam passing through that direction. And, crucially, the signal had to show the exact same characteristics, the same build-up, the same peak, the same fade-out. It is this last point that made the reflection explanation difficult. A reflected signal from a nearby source would not have the same characteristics as a signal from deep space. The brightness profile would be different. The Doppler characteristics would be different. The frequency drift, or lack of it, would not match. Big Ear's detection showed all the characteristics of a signal coming from infinity, from outside the Earth's gravitational influence, from the kind of distance where reflections from any plausible terrestrial source would have produced detectable distortions. There was also the issue of repetition. The next pass of the beam through that same region of sky, 24 hours later, should have shown the same signal if the original broadcast was continuing. The next pass showed nothing. Big Ear scanned the same region day after day for years afterward. No reflected signal of that magnitude was ever recorded again from any terrestrial source bouncing off anything. The reflection explanation also failed. The third explanation was that the signal came from a hydrogen cloud. Cold, neutral hydrogen, in interstellar space, emits a faint signal at exactly the protected frequency. This is, in fact, what made the hydrogen line useful for astronomy in the first place. Natural hydrogen clouds light up faintly at that frequency, and astronomers can map the structure of the galaxy by tracking where the hydrogen is. But natural hydrogen clouds are diffuse. They are extended across large angular regions of the sky. Their emission is weak per unit area. To produce a signal as strong as Big Ear recorded, in a beam as narrow as Big Ear's, would have required a hydrogen cloud of extraordinary density, concentrated in a region small enough to fit inside the beam. Such concentrations are not natural. They are not seen in any other part of the galaxy. They violate the known physics of how hydrogen distributes itself in interstellar space. There was also the question of bandwidth. Natural hydrogen clouds emit across a relatively broad range of frequencies, smeared by the thermal motion of the hydrogen atoms within them. The WOW signal was extraordinarily narrow. Its bandwidth was, by current best estimate, less than 10 kHz. This is far narrower than any natural source produces. No known natural process generates a signal that narrow. The narrowness in the field has always been considered one of the most distinctive features of the WOW signal. It is also one of the features that most strongly rules out natural emission. The hydrogen cloud explanation failed. The fourth explanation was more recent. It was proposed, in 2017 years, by an astronomer named Antonio Paris. He suggested that the signal had been produced by the hydrogen cloud surrounding a passing comet. Comets, as they approach the Sun, release hydrogen and other volatiles into space. The released hydrogen forms a diffuse cloud around the comet. In principle, that cloud could emit at the hydrogen line frequency. If a comet had been passing through Big Ear's beam at the moment of detection, its hydrogen cloud could, in this hypothesis, have produced the signal. Paris identified two comets, designated 266 PC Christensen and P2008 Y2, that, by his calculations, had been in approximately the right region of sky at approximately the right time. The proposal was published. It received significant media attention. For a brief period, it looked as though the OOW signal had finally been explained. The proposal was then examined by the community. The first problem was that comets do not, in observed practice, produce signals at the strength required to match what Big Ear had recorded. Hydrogen emission from comets is faint. Comet hydrogen clouds are diffuse. The kind of concentrated, intense emission that would have been needed to produce a 30 sigma signal in Big Ear's beam was not consistent with what is known about comet behavior. The second problem was that comets, like the rest of the solar system, are slow-moving on the relevant timescales. A comet passing through the beam should have produced a signal that lasted not 72 seconds, but many minutes or even hours, depending on the geometry. The 72-second duration of the WOW signal was a direct consequence of Big Ear's beam sweeping past a fixed point in the sky as the Earth rotated. That is the duration that a stationary source at infinity would produce. It is not the duration that a moving comet would produce. The third problem was that the comets in question had been observed at other times, including by other telescopes capable of detecting hydrogen emission. They had not been observed to produce signals of the kind Big Ear had recorded. They behaved like ordinary comets. Whatever the OAW signal was, it did not match the radio behavior of the comets Paris had identified. The fourth problem was that the comet hypothesis required the comets to have been in a particular position that some independent astronomers, on re-examining the orbital data, could not confirm. The trajectories were not as cleanly aligned with Big Ear's detection direction as the original proposal had suggested. The community, after a few months of evaluation, concluded that the comet explanation did not hold. The comet hypothesis failed. The fifth explanation was that the signal was the result of a secret Cold War broadcast. The 1970s were a period of intense covert communications. The American and Soviet militaries operated extensive networks of classified radio systems. Some of those systems used unusual frequencies. Some of them broadcast in directions that, at the time, were not publicly documented. This explanation has been advanced periodically over the decades. It cannot be definitively ruled out because the full catalogue of military broadcasts in 1977 is not available to civilian researchers. But the explanation runs into the same physical problems as the reflection hypothesis. The signal had the characteristics of a source at infinity. A military broadcast, however covert, would have originated from somewhere on Earth or in low Earth orbit. The geometry of the signal does not match. There is also the matter of the protected band. The hydrogen line frequencies were, by international agreement, kept clear of terrestrial broadcasts. Even classified military programs would have observed this convention to some degree, because broadcasting in that band would have interfered with radio astronomy and would have been detectable by international monitoring stations. A military source deliberately broadcasting in the protected band, in 1977, would have been an extraordinary breach of international convention. No evidence of such a broadcast has ever surfaced in subsequent declassifications. The military broadcast explanation has, for these reasons, never gained traction in the radio astronomy community. It is mentioned occasionally in popular discussions. It is not seriously considered as a plausible cause within the field. The military broadcast hypothesis failed. There have been other proposed explanations. A few are worth mentioning briefly. One is that the signal was a stellar flare from a nearby star. Stellar flares can produce radio emission, but the OBOW signal's bandwidth was too narrow to match stellar flare emission, which is typically broadband. The flare hypothesis failed on the same grounds as the hydrogen cloud hypothesis. Another proposal was that the signal was a previously unknown astronomical phenomenon, some kind of natural source not yet catalogued. This is, in principle, possible. The universe is large. There may be processes that emit narrow-band radio signals at the hydrogen line in ways we have not yet identified. But in nearly 50 years of subsequent radio astronomy, no such process has been identified. No similar signal has been definitively detected from any other source. If the WOW signal was a new natural phenomenon, it would be a phenomenon that has occurred exactly once at the hydrogen line, with no analogue anywhere else in the sky. This is a difficult position. Astronomy generally assumes that physical processes, when they occur more than once. A unique event in a single direction, at a single frequency, with a single duration, with no analogue before or after, is the kind of event that astronomers, professionally, find very hard to accept as natural. It violates the working principle that the universe is uniform, that what happens once happens many times. So we arrive, after walking through every major proposed explanation, at the unresolved question. If the signal was not a satellite, was not a reflection, was not a hydrogen cloud, was not a comet, was not a military broadcast, was not any catalogued natural source, and was not a previously unknown natural process that has somehow never repeated, the field has not given a definitive answer. The signal sits in the catalogue as unexplained. It has sat there for nearly 5 decades. The deeper question, the one we will turn to next, is no longer about what the signal was. It is about the frequency at which it arrived. Because the frequency is, on its own, the part of the story that is most difficult to dismiss as coincidence. Take a slow breath. We are going to spend the next stretch of this video with a fact that, in its quiet way, may be the most disturbing aspect of the entire WOW signal story. It is not the strength of the signal. It is not the duration. It is not the failure of every explanation to account for the source. It is the frequency, the hydrogen line. 1420 MHz. The frequency at which neutral hydrogen, the most abundant element in the cosmos, emits a faint natural radiation. The frequency that every radio astronomer on Earth knows by heart. The frequency that has been formally protected by international agreement from terrestrial broadcasts, specifically so that signals arriving from elsewhere can be evaluated without interference. The WOW signal arrived almost exactly at this frequency, not somewhere in its vicinity, not in a related band, at the protected hydrogen line frequency, with a precision that placed it within the narrow window where any deliberate transmission targeting that line would be expected to fall. Now consider what this implies, if you allow yourself to consider it without immediately reaching for explanations. The hydrogen line frequency is not a natural frequency for arbitrary radio signals. Most cosmic radio emission occurs at other frequencies, distributed across the radio spectrum according to the physical processes that produce them. Pulsars emit at certain frequencies. Quasars emit across broad ranges. Supernova remnants emit in particular patterns. The cosmic microwave background is centered at frequencies much lower than the hydrogen line. The hydrogen line itself is bright when there is hydrogen in the line of sight, but, as we have discussed, the natural hydrogen emission is broad, diffuse, and faint relative to what Big Ear recorded. So, a signal arriving at exactly the hydrogen line is, on its own, statistically unusual. A signal arriving at exactly the hydrogen line, with the brightness and the narrowness of the WOW signal, is statistically very unusual. But the deeper point is this. The hydrogen line is not just any frequency. It is the one specific frequency that, by every analysis the radio astronomy community had performed before 1977, a transmitting civilization elsewhere in the galaxy would deliberately choose if they wanted their signal to be noticed. The reasoning was straightforward. Hydrogen is the most abundant element in the universe. Any civilization capable of radio astronomy would know its emission frequency. The frequency would be universally recognizable. Tuning a transmitter to that exact frequency would be the equivalent of putting a sign on the signal that said, "This is artificial." A natural source would not concentrate at that exact frequency with that exact narrowness. Anyone deliberately broadcasting anywhere in the galaxy would be drawn to that frequency as the most natural calling card. The framework was developed by humans on Earth in the 1960s, by astronomers who were thinking about what signal they would themselves transmit if they were trying to contact an unknown civilization. The reasoning was, choose a frequency that anyone capable of doing radio astronomy would already be paying attention to. The hydrogen line was the obvious choice. It was so obvious that when Drake set up Project Ozma, he tuned his receivers to that frequency. It was so obvious that the international community protected it from terrestrial interference. It was so obvious that, by 1977, every observatory doing SETT work was watching it. The WOW signal arrived exactly there. There are two ways to interpret this. The first way is that it is a coincidence. The signal happened to be at the hydrogen line because some natural process, which we have not been able to identify, happened to produce narrow-band emission at exactly that frequency on that day. The coincidence is statistically unlikely, but not impossible. The universe is large. Rare events occur. We notice them precisely because they are at frequencies we are watching. And we are watching the hydrogen line because we consider it the best place to look. There is, in this interpretation, a kind of observational bias at work. We were listening to the hydrogen line. We caught something at the hydrogen line. The catching is more likely to occur at frequencies where we are actively listening than at frequencies where we are not. So, the appearance of the signal at exactly the hydrogen line might be partially explained by the fact that we were positioned to detect signals at exactly the hydrogen line. The bias does not entirely dissolve the coincidence. Narrowband emission at any frequency would have been unusual, but it shifts the weight slightly. The second way is that it was not a coincidence. The signal was at the hydrogen line because something, somewhere, chose that frequency deliberately, knowing that observers using radio astronomy would be watching it. The choice was not random. The choice reflected an understanding of how radio astronomy works and an intention to be detected. This interpretation has a curious implication that is worth examining slowly. If the source chose the hydrogen line in order to be noticed by observers who would be watching it, then the source must, on some level, have understood that observers like us exist. The source must have anticipated the kind of cosmic listening that radio astronomy represents. The source must have modeled, however abstractly, what a receiving civilization would be doing, and chosen the frequency accordingly. This is not a small assumption. It implies a transmitter that has reasoned about its audience. It implies a transmitter that has, in some sense, considered our existence. The transmitter, if it exists, may never know whether its signal was received. The wavefront passed Earth in 1977. Confirmation of receipt would have to travel back at the speed of light, across whatever distance separates the source from Earth. Even if the source is only 100 light-years away, 200 years would pass between transmission and any confirmation of receipt. The transmitter chose the frequency on the basis of an understanding it could not verify, and an audience it could not confirm. The act, if it was deliberate, was an act of cosmic patience. The field has not formally endorsed the second interpretation. The field has, by professional convention, remained agnostic. The signal is listed as unexplained. The explanations that have been proposed and rejected are documented. The question of whether the frequency selection itself is evidence of intent is, in the published literature, treated cautiously. No reputable journal would publish a paper claiming, on the basis of the OW signal alone, that an extraterrestrial intelligence chose the hydrogen line to attract Earth's attention. But the question sits there. The frequency sits there. The narrowness sits there. The fact that no natural source has been identified, despite 5 decades of searching, sits there. The accumulated weight of these facts, considered together, points in a direction that the field is not yet prepared to formally commit to. You are listening to this in the privacy of your own thoughts. You do not have to commit either. You can hold both interpretations. You can sit with the discomfort of not knowing which one is correct. The radio astronomy community has been sitting with that discomfort for nearly 50 years. You are in good company. Move slowly with what comes next. We're going to walk through one more chapter in the WOW signal story. It is the chapter that sealed the question into its current form. It is the chapter where the most modern instruments humanity has been able to build were turned on the same patch of sky, with the explicit intention of detecting any recurrence of the signal that 1977 had recorded. The chapter ends with a result that the field had not expected, a result that, in some respects, made the original mystery deeper rather than resolving it. By the 2010s, several things had changed since the original WOW signal detection. Radio astronomy instruments had become enormously more sensitive. Telescopes like Arecibo in Puerto Rico, the Very Large Array in New Mexico, the Green Bank Telescope in West Virginia, and others around the world, could detect signals far weaker than anything Big Ear had been capable of. They could resolve narrower bandwidths. They could integrate longer observations. They could distinguish between celestial sources and terrestrial interference with much greater precision. In addition, the analysis of the original WOW signal had improved. The exact coordinates of its detection had been refined. The error bars on its location had been calculated. Researchers had narrowed the region of sky from which it must have originated to a small patch in Sagittarius. The patch was small enough that a sensitive modern telescope could target it specifically, and if anything similar was still being emitted from there, would, in principle, detect it. The first major follow-up attempts had begun, in fact, much earlier. In the years immediately after the original detection, Big Ear itself had continued to scan the same region of sky each day. The astronomers at Ohio State had paid particular attention to that patch as it passed through the beam. They had found nothing. The signal had not repeated within the first year. It had not repeated within the second year. It had not been repeated by the time Big Ear was decommissioned in the late 1990s. 2 decades of continued listening from the same instrument had produced no second detection. Other telescopes joined the follow-up effort sporadically. The Very Large Array conducted observations in the 1980s. The Mount Pleasant Radio Observatory in Tasmania looked. The Hat Creek Radio Observatory looked. None of them found anything matching the original signal. The accumulating absence of detections was, by the 1990s, beginning to look definitive in one respect. A program was organized. The Arecibo Observatory was used in 2020 for an extended observation of the WOW signal region. The Green Bank Telescope contributed additional observations. Researchers worked through the data carefully. They knew what they were looking for. They knew the characteristics of the original detection. They knew the frequency, the bandwidth, the duration profile, the directional precision. They had a complete fingerprint to match against. The Arecibo observation was particularly significant because of what Arecibo represented. The telescope had been, for decades, the largest single aperture radio telescope in the world. Its sensitivity was orders of magnitude greater than Big Ear's. If a signal of even a small fraction of the WOW signal's strength was still arriving from the same region, Arecibo would, in principle, detect it. The Arecibo observation was, in some sense, the the most thorough check that the AWAW signal source was still active in its original direction. They looked. They listened. They processed the data carefully. They found nothing. The region was silent. At the hydrogen line, at nearby frequencies. At any frequency they checked, the patch of sky that had, in 1977, produced one of the most striking signals in the history of radio astronomy was, in 2020, indistinguishable from any other random patch of sky. Background noise. The cosmic hiss. No signal. The result was reported. The community evaluated it. The conclusion was that, with current instruments and observing methods, no recurrence of the AWAW signal had been detected. It should be acknowledged here that the Arecibo Observatory itself, shortly after these observations were completed, suffered a catastrophic structural failure. The main reflector dish collapsed in late 2020. The telescope is no longer operational. The observations performed in the months leading up to the collapse were, in this respect, among the final scientific contributions of one of the most consequential radio astronomy facilities ever built. The instrument that conducted the most thorough search for the WOW signal's source is itself no longer there. The data the instrument collected remains. The collapse adds, to the long history of this story, a small additional weight. The most sensitive search ever performed by the most powerful single-dish radio telescope ever constructed returned no result. The telescope did not survive much beyond the search. This sounds, on first hearing, like it might be a resolution. If the modern instruments cannot find anything, perhaps the original signal was simply a one-time event that has not repeated, and the mystery, while unresolved, is at least bounded. We can say that, whatever the source was, it is not currently active. The signal was a fluke. We can move on. That is not quite the right way to interpret the absence. Sit with this carefully. A one-time signal from a single location that does not repeat is itself an extremely unusual event. Natural astronomical processes tend to repeat. Pulsars pulse. Quasars flicker. Even rare transient events like supernovae are observed multiple times per year across the sky. A radio source that emitted one bright, narrow-band signal at the hydrogen line for 72 seconds in 1977, and then went silent forever, is not the kind of source that any natural astrophysical category easily contains. The natural sources astronomy has catalogued either emit continuously, or emit periodically, or emit in burst patterns that recur. None of them emit exactly once, at exactly the hydrogen line, with exactly the precision of a deliberately tuned transmitter, and then vanish. If the WOW signal was natural, it represented a class of natural phenomenon that has been observed exactly once, by exactly one telescope, at exactly the frequency that human radio astronomy was set up to monitor for artificial signals. The probability of such a coincidence is not zero. It is, however, statistically uncomfortable. If the WOW signal was artificial, the absence of repetition has a different interpretation. An artificial transmitter is not obligated to broadcast continuously. It might broadcast at intervals. It might broadcast on a schedule that does not match Earth's observing windows. It might broadcast in directions other than ours most of the time. The absence of repetition in 2020 does not rule out an artificial source. It only rules out an artificial source that is currently broadcasting continuously toward Earth. There is also a third possibility. The signal might be artificial, and might have been produced by a source that was, in 1977, broadcasting in a direction that swept across Earth briefly. The source might have been moving. Its directional beam might have rotated. Once the beam moved off Earth, the signal would no longer be detectable here. we would have caught the signal during a single sweep of the beam, lasting exactly as long as the beam was pointed at us. 72 seconds. After that, the beam moved elsewhere. We would never hear from that source again, unless its beam happened to sweep back across us at some future date. This third interpretation is, in some respects, the most disturbing one, because it implies that the AIUO signal might have been just a fragment of a larger ongoing transmission, of which Earth received only the briefest passing glance. The transmission might be continuing now, pointed at some other star, some other region of the galaxy. We caught its edge. We did not catch its substance. The signal we received was, in this view, not directed at us. It was a stray spillover from a transmission directed at someone else. The astronomers who have considered this scenario over the decades have not been able to definitively prove it or disprove it. The data is consistent with all three interpretations: natural anomaly, deliberate brief transmission, fragment of an ongoing directed transmission elsewhere. The data is not sufficient to distinguish them. That is where the field sits now. After Arecibo, after Green Bank, after every modern follow-up, the signal has not repeated. The absence of repetition has not resolved the question. It has, instead, made the question harder. Let the implications settle for a moment. If the source is natural and unique, our cosmology has a category we do not yet recognize. If the source is artificial and brief, we caught a deliberate one-time transmission. If the source is artificial and ongoing, we caught a beam in passage. None of these possibilities is comfortable. None of them has been ruled out. We are going to spend the rest of this video with the longest running version of the question. The version that the field cannot dismiss. The version that the absence of repetition, the persistence of the frequency selection, and the failure of every natural explanation together imply. Slow down with what follows. The implications are not loud. They are quiet. But once they are in your awareness, they do not leave. The signal is, in one technical sense, gone. It happened in 1977. It has not been redetected. It exists now only as a record on a piece of green bar paper in the archives of the Ohio State University Radio Observatory. In another sense, the signal is not gone at all. Whatever produced it is somewhere. The source did not vanish. Sources do not vanish. They continue to exist after they emit. Whatever emitted the SAWOW signal is, at this very moment, somewhere in the galaxy. It is in the direction the signal came from. It is at the distance the signal traveled to reach us. It has been there the whole time. It has been there before 1977. It has been there since. We do not know how far away the source is. The OOW signal could have come from a nearby star system, in which case the source is within a few hundred light-years of Earth. It could have come from the far side of the galaxy, in which case the source is many tens of thousands of light-years away. The directional precision of Big Ear's detection narrows the angular position, but it does not constrain the distance along that line of sight. The source could be anywhere along a long radial line extending out from Earth towards Sagittarius. What this means is that the signal we received in 1977 was not contemporaneous with the act of transmission. The signal was emitted some time ago. If the source is 100 light-years away, the act of transmission occurred 100 years before 1977. If the source is 1,000 light-years away, the act occurred 1,000 years before. The transmission has been crossing space for as long as the source's distance from Earth, in light-years, and however long it has been broadcasting before that. Now consider what this means about the source's current state. If the source was actively transmitting in 1977, The moment of transmission was already in the source's distant past. The source has continued to exist, presumably, since then. If the source continues to transmit in the way it transmitted then, signals it sent more recently are still on their way to us. They have not yet arrived. They are, in some sense, still in transit across the void. If the source emitted one strong burst in our direction, the burst has passed. It will not return. But signals it emitted in other directions, before and after the burst we received, are still propagating. Some of them may, by sheer geometry, eventually intersect Earth at later times. We cannot predict when. We can only know that, if the source continues to exist and continues to emit, the universe is still carrying its signals through interstellar space. There is a sense in which the WOW signal is not a single past event. The act of transmission was a moment. The wavefront of the transmission, however, has been spreading outward from the source since it was emitted. The wavefront swept past Earth in 1977. The wavefront, by now, has moved on. It is currently sweeping past stars beyond the solar system. It is still moving. It is still carrying the same information it carried when it reached us. Other wavefronts, from other moments at the source, are still in transit. They are at various distances from Earth, depending on when they were emitted. Some may arrive in our future. Some may have already passed Earth at times when we were not observing. Some may have passed Earth at times when our instruments were not sensitive enough to detect them. The signal we received was one slice of an ongoing emission. It is unlikely to have been a unique slice. It is unlikely to have been the only one. This is the implication that the field has been holding open. The implication that whatever produced the "oh wow" signal is, with probability approaching 1, still there. Either as an active source, in which case more transmissions are en route, or as a no longer active source whose past transmissions are still propagating through space and may yet intersect Earth at some future moment. Either way, the signal we received was a contact with something that exists, or at least existed. The contact was brief. It was, in human terms, instantaneous, but it was real. The data is on the printout. The numbers are there. Whatever the source is, whatever it was doing, whatever it intended or did not intend, it produced a real signal that reached a real telescope on a real day, and the signal has not been explained. Hold this for a moment. Let it sit. You are not being asked to believe anything in particular. You are being asked to acknowledge what the data implies. Something produced the WOW signal. The producer of the signal was not random. The frequency was the hydrogen line. The bandwidth was narrow. The strength was extraordinary. The duration matched what a stationary source would produce. The location is known to be within a small patch of sky in Sagittarius. Something is in that direction. We do not know what. We know what it is not. Not a satellite, not a reflection, not a hydrogen cloud, not a comet, not a military broadcast, not any catalogued natural source. We know what it appears to share with deliberate transmission, frequency selection, bandwidth narrowness, peak intensity, propagation characteristics consistent with deep space origin. The field has stopped short of saying what it is. The field has not stopped short of leaving the question open. There is a particular quality to scientific questions that remain open for long periods. They acquire weight over time. Each year that passes without resolution adds to the weight. The weight is not the weight of certainty. It is the weight of accumulated unsuccessful attempts. The field has tried to explain the WOW signal. The field has not succeeded. The duration of the failure is itself, at this point, evidence about the nature of what is being looked at. A signal that resists explanation for 47 years is, in the practical history of radio astronomy, a signal that may not be amenable to explanation by any of the categories the field currently possesses. Consider what this implies. Most unexplained signals in most fields of astronomy do not remain unexplained for long. New data arrives. New methods are developed. New instruments are built. The field as a whole gets better at categorizing what it sees. Anomalies that puzzle the field in one decade are typically resolved within the next 2 or 3 decades, either by being recognized as instances of new natural phenomena or by being identified as artifacts of detection methods that improved instruments have since eliminated. The WOW signal does not fit this pattern. It has resisted 4.5 decades of progressively better instruments and progressively more sophisticated analysis. The persistence of its unexplained status is, on its own, unusual. The question is open. It has been open for 47 years. It will continue to be open until something changes. We are now in the final stretch of this video. Let the pace slow further. The remaining time will be spent with the location itself. The signal came from a specific direction. The direction is in the sky. The direction is reachable in the sense that, on any clear night, you can look up and identify the region of sky where it came from. The coordinates have been published. The constellation has been named. The reference stars are visible to the naked eye on a dark night. The direction is in the constellation Sagittarius. Sagittarius is one of the southernmost constellations visible from the northern hemisphere. From the latitude of Ohio, where Big Ear was located, Sagittarius appears low in the southern sky during summer evenings. The signal arrived in mid-August, in the early evening hours by Eastern Daylight Time, when Sagittarius would have been crossing the southern meridian. The specific patch of sky from which the signal came is identifiable to anyone with a star chart and a clear horizon. The position is approximately at right ascension, 19 hours 25 minutes, declination -27 degrees. The position falls in a region of Sagittarius that contains a number of well-known features: the bright star clouds of the Milky Way, several globular clusters, the Lagoon Nebula, the Trifid Nebula, the galactic center itself, which lies in the same general direction. The patch is rich with catalogued sources. None of them, by current understanding, can have produced the signal. There is, in the patch, a star designated Tau Sagittarii. The star is bright enough to be visible to the naked eye on a dark night. It sits roughly in the direction the signal came from. It has been examined by astronomers as a candidate source. The examination has not produced evidence that Tau Sagittarii itself produced the signal. The star is, by every available measurement, an ordinary K-type giant of a kind that is common throughout the galaxy. It does not have any of the radio properties that would suggest it is responsible for what Big Ear recorded. But Tau Sagittarii serves a purpose for the observer on Earth. It is a marker. It allows the listener, on a clear night, to look at a specific bright point in the sky and know that they are looking near the direction the signal came from. The signal source itself, whatever it is not necessarily near Tau Sagittarii in physical space. The two are in the same line of sight from Earth, but their distances along that line of sight may be very different. Tau Sagittarii is, by current measurement, about 120 light-years from Earth. The signal source could be at the same distance, or could be much closer, or could be much farther. We do not know. What this means, practically, is that the location of the OWOW signal is in a region of sky that anyone watching this video can, on a clear summer night, look up and find. The constellation is recognizable. The teapot shape of Sagittarius is one of the more distinctive patterns in the sky. The patch where the signal came from is, in human terms, locatable. If you live at a northern latitude, you can stand outside in late July or August, look toward the south, find Sagittarius, and let your eyes settle on the region the signal came from. You can do this. You can do it tonight if the sky is clear and the time of year is right. Now sit with what looking does. When you look at that patch of sky, you are not seeing the wow signal. The signal has long since passed. You are looking at the direction the signal came from. The source of the signal, whatever it is somewhere along the line of sight your eyes are tracing. The source has been there the whole time. It was there when Jerry Eman wrote the word in red ink. It was there before that. It is there now. The light reaching your eyes from that direction is light that left the various stars and galaxies in that line of sight at various times in the past. The closer stars sent their light to you years ago. The farther stars sent their light centuries or millennia ago. The most distant features along that line of sight sent their light tens of thousands of years ago. Your eyes, in any moment of looking, are receiving photons that span an enormous range of cosmic times. Somewhere along that line, somewhere among those photons, is the source that produced the signal we recorded. The source has been continuing to do what it does, whatever that is. Most of what it does, presumably, does not produce hydrogen line emission at 30 sigma intensity. Most of what it does is presumably invisible to us. But the one event we recorded is not unique in the source's history. It cannot be. Sources do not exist for a moment. Sources exist for durations. The event was one moment in the source's ongoing life. When you look at the direction, you are not seeing the source. You are seeing the direction the source is in. The source is some distance along that direction. You cannot, with your eyes alone, distinguish between things at different distances along the line of sight. You see a flattened image of the sky. The depth collapsed. The source could be anywhere along that depth, but it is there. Something is there. It is in the direction your eyes are pointed. It is at a distance you cannot determine without further data. It is producing, presumably, the signals it produces, whatever they are, on whatever schedule it follows, in whatever directions it broadcasts. Most of that activity is not directed at Earth. Some of it, at one moment in 1977, was. That is the situation. That is what the data implies. There is no resolution to offer here. The field has not resolved this. The signal sits in the catalogue. The location sits in the sky. The question sits in radio astronomy as one of its oldest open files. Let yourself rest with the location now. As you fall towards sleep, you can hold the direction in your mind if you choose. The teapot of Sagittarius. The bowl of stars. The patch above the bowl, slightly to the side. Somewhere there. A direction, a region. A presence whose details we do not know, but whose existence is recorded in numerical readings on a piece of paper from August 1977. You do not need to interpret it. You do not need to assign it meaning. You only need to know that the location is there, in the sky, in the same place it was when the signal arrived, in the same place it has been every night since. Whatever produced the signal is, in some form, still in that direction, either still active, in which case other signals are in transit, or no longer active, in which case its past signals are propagating through space in directions we cannot predict. The field has been listening. The field has not heard a repetition. You can listen too. Not with radio telescopes, with awareness. The awareness that, in the direction of Sagittarius, something is sitting in the data of 1977 and the data of every year since, as an unresolved presence. The presence is not loud. The presence does not call attention to itself. The presence simply continues to exist in the location it has always occupied. That is the location. That is where it is. It has been there for at least 47 years from our perspective. It has been there for much longer than that from the perspective of the source. The signal we received was an old signal. Old in human time. Old in light travel time. The act that produced it occurred decades or centuries or millennia ago, depending on the distance we do not yet know. The act has propagated. The wavefront has spread. The wavefront passed us in 1977. The wavefront is now somewhere out beyond the solar system, still expanding outward through interstellar space, carrying the same information it carried when it reached Earth. It will continue to expand. It will continue to carry the information. Eventually, in cosmic time, the wavefront will reach observers at other locations in the galaxy. If such observers exist, they will receive what we received. They will see the same numerical pattern that Jerry Amon saw in the morning of August 15th. They will, perhaps, draw their own arrows. They will, perhaps, write their own marginal annotations in whatever language they use. The signal is not ours alone. The signal is propagating. The signal will continue to propagate. The galaxy is, in this sense, hearing the same thing we heard on its own schedule, in its own places. This is the largest scale at which the question sits. The signal was not a private event between Earth and an unknown source. The signal was a cosmic event. The wavefront crosses the galaxy. The information it carries is, in principle, available to anyone in the galaxy capable of detecting it. We caught one part of the wavefront as it swept past us. Other observers, at other locations, will catch other parts as the wavefront sweeps past them. Consider for a moment what this means about the act of detection itself. The wavefront did not stop when it reached Earth. Big Ear caught a single thin slice of it as it passed. The reflectors gathered some of the energy. The detectors recorded the gathering. The printer printed the numbers. Jerry Amon, days later, circled them. The act of detection consumed an infinitesimal fraction of the wavefront's total energy. The rest of the wavefront continued past Earth, continued past the Moon, continued past the outer planets, continued past the heliopause where the solar wind gives way to the interstellar medium, and continued onward into the void between stars. The wavefront is still expanding. It has been expanding for 47 years longer than at the moment we caught it. The wavefront's leading edge is now, by the simple arithmetic of light travel, approximately 47 light-years farther from Earth than it was on the day of detection. The wavefront passed through Earth's location and kept going. The portion of it that reaches us, in any future moment, is the portion that was emitted later than the portion we have already caught. There is no going back to the original wavefront. The original is gone. Only the later portions of the source's emission, if any, remain available for our future detection. The geometry of cosmic communication has this quality. A transmitter emits. A wavefront propagates. A receiver, somewhere along the wavefront's path, intersects the wavefront for an instant. The intersection lasts as long as the wavefront's thickness divided by the speed of light, which is, for any reasonable signal, very brief. Then the receiver and the wavefront separate. The wavefront continues past. The receiver retains whatever fraction of the wavefront it managed to capture during the brief intersection. The intersection cannot be repeated for that particular wavefront. The wavefront, by definition, only passes once. Any further communication requires a new wavefront, emitted later, traveling later, arriving later. The WOW signal was our brief intersection with one wavefront. The wavefront has gone. Whatever future wavefronts the source may have emitted, or may yet emit, are at various stages of their own journeys. Some may be approaching Earth now. Some may pass Earth at times when our instruments are not pointed in the right direction. Some may never pass Earth at all, because the source's beam may be pointed elsewhere. The geometry of detection is precarious. It depends on the source's pointing, on our pointing, on the alignment of both at a moment when the wavefront happens to be crossing our location. The alignment is rare. The alignment, in our cosmic history, has happened conclusively exactly once. We are not unique in receiving the signal. We are merely the only known observers who have, so far, processed it. Other observers, if they exist, may have already received their portion of the wavefront, or may receive it in some future moment of their own time. The signal is, in this sense, a galactic event. The galaxy is full of stars. The galaxy is large. The wavefront has been crossing it for as long as it has existed, and will continue to cross it for as long as the cosmic structure permits. Now let your attention return to the immediate, to the room, to your own breath, to the listening that has been happening as you have followed this account. You have spent the duration of this video with an unresolved presence. The presence has not been demanding. The presence has not been threatening. The presence has simply been there, in the data, in the direction, in the question. You can let the presence remain. You can sleep with the presence of your awareness. Your presence does not require anything from you. It does not require belief. It does not require explanation. It does not require attention beyond what you choose to give it. It has existed without your attention for nearly 50 years. It will continue to exist whether you attend to it or not. But you are now part of the small group of people who have, with focused attention, walked through the full history of the AWAW signal and the long failure of explanation that has followed. You hold the same unresolved presence that radio astronomers hold. You can sit with it as they have sat with it. You can let it accompany you into sleep tonight, and into the mornings of the days that follow, and into whatever moments of looking up at the sky you choose to take in whatever future nights are still ahead. The patch is in Sagittarius. The teapot shape, the bowl of stars. Something is there. Something has been there. Something will continue to be there. The signal was the briefest possible contact, 72 seconds. A single moment of mutual presence between a source and a detector, separated by a distance we have not measured, connected by a wavefront that crossed the interstellar void. The contact has ended. The presences have not. The source is somewhere in Sagittarius. The receiver is here, in this room, listening to the account, holding the awareness of what was recorded and what was not explained. Both presences continue. The source continues, presumably doing what it does, at whatever cadence its existence permits. The receiver continues, listening in the way a human listens. Not with radio dishes, but with the kind of attention that, having once received a signal, does not entirely let it go. You will sleep tonight in the same room as you have slept many nights before. The direction is still in the sky. The teapot of Sagittarius is, depending on the time of year, either above the horizon or below it. The signal source is, regardless of horizon, still in the same place, on the same line of sight, at the same unmeasured distance. The signal will not arrive again tonight, in all probability. The Arecibo follow-up showed that, as far as our instruments can determine, the source is not currently broadcasting in our direction at the strength that 1977 recorded. But the wavefront from that original event continues to propagate. The signal source continues to exist. The question continues to sit in the field. You can let all of this settle as you drift towards sleep. The story is, in some technical sense, complete. We have walked through every major proposed explanation. We have seen each one fail. We have considered the meaning of the frequency selection. We have considered the absence of repetition. We have considered the implications of the location. There is no more to add tonight. There may be more in some future year, when new instruments detect new signals from the same direction, or when new analyses of the existing data reveal patterns that current methods have missed, or when whatever the source is changes its behavior in ways that produce new evidence. Until then, the file remains open. The patch remains in the sky. The signal has not been explained. The signal source, in whatever form it takes, continues to exist along a direction that you can locate with your own eyes if you choose to look. Slow your attention now. Let the breath lengthen. The direction is there. You can carry both into the night that is now ahead of you. The teapot, the bowl, the region above. Something is in that direction. Something was there before any of us were listening. Something will be there after all of us have stopped. That is what the data implies. That is what the field has held open for 47 years. There is a particular kind of presence that exists at a distance. It does not interact with the immediate environment. It does not influence the room you are in. It does not shape what happens to you in the hours ahead. It simply exists at a distance, in a direction, with characteristics we have partially measured, and consequences we have not fully worked out. Most of cosmic existence is the presence of this kind. The stars in the sky are presences at distances we cannot reach. The galaxies beyond the stars are presences at distances we cannot meaningfully imagine. The signal source in Sagittarius is one more presence at one more distance, added to the long list of cosmic features that the universe contains, and that we, from our small position, can only acknowledge. But the WOW signal source has a slightly different character than the other presences. The stars do not appear to have noticed us. The galaxies certainly have not. The signal source, on the most disturbing interpretation, may have noticed us. It may have transmitted in a manner consistent with knowing that observers like us would be watching. The signal source is, in this respect, a presence that may have, in its own way, considered our presence first. That is not a comfortable thought. It is also not a thought that the data forces on you. The data is consistent with multiple interpretations, the choice of which to hold is yours. You can hold the natural coincidence interpretation. You can hold the deliberate transmission interpretation. You can hold the ongoing beam passing by interpretation. You can hold all three in suspension, as the radio astronomy community holds them, and wait for further data that may eventually narrow the possibilities. The waiting is what the field has been doing for 47 years. The waiting is what you will be doing too, if you continue to hold the question. That is the location. It is in the sky above Sagittarius. You can look toward it tomorrow, if the night is clear and the time of year is right. The signal will not return on schedule. The direction will hold. The constellation has been in the same approximate part of the sky throughout recorded human history. The stars of Sagittarius have moved very slightly across the millennia, but at human timescales the constellation is, for practical purposes, fixed. Ancient civilizations looked at the same configuration of stars. They gave it different names. They told different stories about it. None of those stories included the possibility that, on a specific summer evening in the second half of the 20th century, a signal would arrive from approximately that direction, and that the signal would resist explanation for the rest of human history so far. The ancients did not know. We barely know. The field knows what it does not know, which is significant but limited. The signal arrived. The source remains in the direction. The explanation has not arrived. Each of these statements has been true for 47 years. And will continue to be true tomorrow. Quiet now. The story is complete in the sense that we have walked through it. The story is not complete in the sense that its central question has been answered. The location is named. The presence remains. There is nothing more to add. The video has spent its duration with one of the longest-running open files in radio astronomy. The file remains open. The patch remains in the sky. The wavefront has long since moved on. The source, by every reasonable assumption, is still there, doing whatever it does, on whatever schedule it follows. You have given 2 hours of attention to this. The 2 hours have, in their own quiet way, joined you to the small community of observers who have sat with this question across the decades. The community is not a formal organization. It is simply everyone who has, at some point, taken the question seriously enough to follow it to its current state. You are now in that community. The membership requires nothing further from you. You can let the question recede. You can let the location fade from immediate attention. You can return to the ordinary concerns of ordinary days. But the direction will remain in the sky. The next time you happen to look up on a clear summer night, the teapot of Sagittarius will be there if the season is right. The patch above the bowl will be there. The line of sight along which the signal traveled will be there. The source, presumably, will be there too, somewhere along that line, at a distance we have not measured. You do not need to look. Looking is optional. The presence does not depend on the looking. But if you do look, you will be looking at a direction that has, in the data of 1977 and in every analysis since, contained a presence that radio astronomy cannot explain. The looking will not give you any additional information. The looking will simply be a small act of acknowledgement. You acknowledge, with your own eyes, the direction in which something has been waiting to be understood. Sleep now. The direction is in the sky. The presence is in the direction. The question is open. The question has been open for 47 years. The question will be open tomorrow. Sleep.